Hello, and welcome to SudoKanard. This Sudoku puzzle was featured, believe it or not, in WPF Puzzle Grand Prix. The round was organized by Serbia, and all the titles of the puzzles began with an S, and there was Sudoku, just plain Sudoku, and this Serbian frame Sudoku, which makes sense for Serbian author. The author of this very puzzle is Zoran Tanasić, and it was worth a whopping 62 points, 66 points, if I recall correctly. And this puzzle was much less hard than what you get for this amount of points in a Sudoku Grand Prix. Right, so the rule of Serbian frame is that whenever you have a number on top, it must be the sum of the digits in the third and fourth digit in the corresponding column. And those are indicated by the white dots. So 17 is the sum here, 3 is the sum here. And horizontally it's different. Every digit is the sum of the second and the third in the row. And that's starting from the left or starting from the right. So let's begin. Some sums are very constrained. 3 can only be 1 and 2, 17 can only be 8 and 9. And you can see that this 17 is also 8 or 9. This 11 now is either 2, 9 or 3, 8. This 15 is either 6, 7 or 8, 9, but in this column, this can only be a 6 or a 7, and this is 8 or 9. Now, let's have one more look. Well, the rest here is a bit trickier. And the other side doesn't seem very helpful. Oh, this 17 can only be 7 plus 9. So where should we look? Well, this 14 is either 6, 8 or 5, 9, but there's already 8 and 9 here. So this is the smaller digit and the higher at the bottom. Then something that might be of interest is that when you take 2 full columns here, the total sum of the digits is 2 times the digits from 1 to 9, which is 90. And if you add up all those numbers, you should have 90 minus this number. So that's 20, 31, 46, 56, 65, 74, 82. So the sum here is 8, meaning that the sum of those two digits is 8 without using 1 and 2, so that's 3 and 5. I'll remove this digit. So we know now that there's a 6 somewhere here, and this can't be a 5. So that's 5, that can't be a 6, sorry. So that's 5 and 9, that's a 7, that's a 9. And so that's something interesting. Let's do the same computation here. 22, 35, 46, 56, 64, 74, 81. So the sum here must be 9. And we'll come to that at some point. Now, what else do we have? The sum of all digits here should be 45. We already have 5, and the sum of these is 36. So that's 41, and the digits here must have a sum of 4. So there must be a 1, 3 there. And then 1 here would put a 9 there. That's not possible, so that's 3 and 7, that's a 1. And then this is 2. To complete this 11, that's a 9, that's 8, that's 9. That's 8, and to complete the 15, that's a 7. And there we get a 4, 6 pair here. This 2 also resolves the 1-2 pair on top. Here we have a 4-6 pair. At the bottom we got a 2-8 pair. And let's ponder what is happening. Here we have 2 dominoes summing to 9 without using 2 or 8, which means that 7 can't be in them because 7 would need a 2 to complete the 9, and similarly 1 can't be in it because 8 would need an 8 to complete to 8. So 1 and 7 are here, and that makes 8, which is good. This 4-6 is in a 10 sum, so that's 4 or 6. Up there, this 3-5 has its counterpart here. To complete to 9, we get 4-6, and this is 3 or 5. And I think that's all we can do with those columns for the time being. So where do we look next? This row looks promising. We have 8, 7, 5. This 11 now can only be 2 and 9. And the missing digits are 3, 4, 6. Do we have something about this 10 sum? It can't use a 2 or a 9, or it can't be 4, 6, so it has to be 3 and 7. So that's not 3. And to complete this 9 sum, it's with a 6 or a 2. And with this 8, that's a 6 or a 2 as well. So now we get 4 here, 5, 6, 4, 6, and 3. And this row still needs 1, 3, and 8. But here we must complete to 5. So 8 is too big. 1 would put a 4, which would repeat in the row. So that's a 3, that's a 2. 1, 8 here, 1, 8 here, and to complete to 9, that's the other digit, and actually it's also 1 and 8 here. This 13 now can't use a 9, can't use a 7, so it has to be 5 and 8. So this is now 1, 8, 1, 8. So that's already resolved, and this is 4 or 6. And to complete to 9, we get 5 or 3. Alright, and here to complete to 9, we get 4 or 1. And to complete to 9 here, 1 would need an 8. That doesn't work. So that's a 4. That's 5, 8. That's a 5 as well. So that's a 3. This is 6, and that's 4. Removing 4 from those cells. Here we need 1, 4, and 7. That's not 7, that's not 1. And actually, these 3, I've been missing this since the beginning. That's 1 and 2. This 8 can't be 4 plus 4, so that's 7 and 1. That's a 4. And this can only be a 6. Where should we look next? Here, it doesn't use a 2 or a 6, nor a 3, so that's 1 and 9. This 7 can't use a 1 or a 2, so it's 3 and 4, so that's 3, that's 4. It resolves this 7, 3 pair. 7 goes with a 2, and that's a 6. That's a 2, that's a 9, that's a 1, that's a 9. All of this resolves quite nicely. Here we need a 7 and a 5. Note that the 2-8 pair isn't resolved yet. This 13 doesn't use a 4 or a 5, so it's 6 and 7. And here we get 8 and 1, which is consistent with this 9, but we didn't need the 9. That's a 2, that's a 9. This 6 resolves 4-6 pair here. And now the rest should be plain Sudoku. This 3 makes this 6 and this 3. Oh, that's a 5, that's a 3. And let's have a look at this. So this is 5, 8, and 3. So that's a 3. Surrounded by 5 and 8. That's 4, 7, 9. So that's 4. That's 7. That's 9. Down there, 5, 8, and 6. 6 can only be here. So that's 5 or 8. Here somewhere we need a 9. It can only be here. That's a 2. Resolve the 8-2 pair. So that's 5. And we resolve the 8-5 pair. And the missing digits are 4 here, 8 there. And that's it. So really, for 66 points, that was a bargain, I'd say. Well, except that, as you know, your dear Canard, I tend to break the puzzles, and I did break this one during the contest. Well, I just erased my markings and started it all over again, and all was well. So thanks for watching this video. Thanks to the team of Serbian authors who provided a magnificent round, and see you soon on SudoKanard.